geometric series. The sum of the first n terms of the series. So we're looking for a formula. So if I list all of my terms, so we have the sum of n terms, first term. The second term is the first term multiplied by r. Okay, so we're doing this times r. If you keep doing the same, the next one will be ar times r, ar squared, ar cubed, and so on. And this is the last term and one term before the last term. Now I'm going to multiply both terms, well, both sides of this equation by r. So I'm going to multiply this by r and this. If I multiply by r here, if I multiply by r here, so you've got a r to the n minus 2 times r to the power of 1, and if you add these indices together we get a r to the power, so n minus 2 plus 1 gives you n minus 1, and if we do the same for the last one, a r to the power of n minus 1 times r. If you add the indices here, you get a r to the power of n, the minus 1 plus 1, they will cancel. So this was the original series. I've undone the little changes that I just made. I've multiplied both sides by r, and now I'm going to subtract 1 minus 2, and when we subtract ar minus ar, they cancel. A term from here will cancel with a term from here, and so on. That would have cancelled, that would have cancelled. What you're left with are these terms, and this minus this. So we've subtracted one from the other. Minuses because we were subtracting. Okay, so if I factorize here, there's a sum of n terms in both terms here, take that out, and then divide by 1 minus r to leave the sum of n terms, and this is a formula that's in the formula book. So a simple example, the sum of the first 10 terms of this geometric series, so a is 2, we're multiplying by 3, the common ratio, n is 10, we want the sum of 10 terms. Substitute the values into the formula, and the final answer. Example 3, so we have a series, it's geometric, the first term is 1024, the common ratio, if we take two consecutive terms, the term on the right, it's negative, divided by the term on the left, so we have the common ratio. To work out the number of terms, you have to focus on the last term in the series. We need to write down the nth term formula for the last term. So here's my nth term formula. So substituting the values in that we have, and the last term was 1, this. We know what a is, we know what r is, and then we solve. So I'm dividing by 1024, and the power here, it goes on the numerator and the denominator of this fraction, like this. Now minus 1 to the power of n minus 1, if we just look at this part separately, so we've got minus 1 raised to an odd power we'll get minus 1, and raised to any even power we will get plus 1. So it's either 1 or it's minus 1. Now it has to be positive, so it's got to be plus 1, because the left hand side of the equation here is a positive value, the denominator is positive here, so the numerator must also be positive. You know, a positive number divided by another positive number gives a positive number. So we know it's going to be equal to 1. So I can simplify all of this to just 1. And then if I do the reciprocal on both sides, or you can cross multiply, we're looking for a power, so we can think of logs. The base here was 2, so I've taken logs to the base 2. I'll bring the power to the front using the power law of logs. And this is from your calculator, gives you 10. So n is equal to 11. So this is the first term, second term, third term, and this is the 11th term, where n is equal to 11. The sum of the first 11 terms, we can use the Sn, sum of n terms formula, substitute the values in, put this all into your calculator, use brackets appropriately in your calculator, like the minus a half, put that in brackets. 683. Example 4. When does this geometric series exceed 2 million? Okay, so a equals 1, the common ratio is 2, and we're looking for the sum of the series to exceed 2 million. Not a particular term, but the sum of the series. So we're using the sum of n terms formula. If we put the values in to our formula here, so what we have is this: the sum of n terms is greater than 2 million. That's what we're solving. 1 minus 2 gives you minus 1. So because minus 1 is a negative number, so this is now negative, I've multiplied that minus 1 with the other side, with both sides. So if you're multiplying by negative numbers with inequalities, you have to reverse the direction of the inequality. To get rid of the 1 here, I'm going to subtract 1 from both sides. So this becomes, on the right hand side, you get minus 2 million and 1. If you subtract 1 from each side, multiply both sides by minus 1, so you're changing signs. Again, if you're multiplying both sides by minus 1, then you have to reverse the inequality. So it goes from less than to more than. Take some logs. Use the power rule, the n will come to the front when you take logs. And we know that log 2 to the base 2 is 1. The value of this from your calculator. N is greater than 20.9. N is an integer, so the first integer greater than 20.9 is 21. So if we were to add the first 20 terms, if you worked out this, the sum of the first 20 terms, it would not exceed this value. But if you have the sum of the first 21 terms, it will exceed 2 million. For practice, try these questions.